Well, hi, and welcome to my shop this morning. I'm going to be doing a fairly detailed visual inspection of the amplifier here. This is a number 245 Victor amplifier. And of course it goes with the receiver. In the last video you saw me playing all this stuff. So today what I want to do is just do a very close visual inspection of this. I've done a preliminary inspection long before I ever turned it on and the like. But we're going to do a much closer inspection now of the unit. So let's just start with this long camera shot here. What do we see? Actually, let's start with the top. What do we see here? Well, okay, so we see the tubes, we see all these cans. These cans look to me like they cannot be entered into. These aren't meant to be taken apart. Pretty sure a lot of these are filled with tar or compound of some sort to occlude or push out any air that might be in here. And what's in these would be a couple of big transformers and a couple of sort of multi-section capacitors, I believe is what all these are. Which is which? I don't know. Can we see underneath? Okay, so let's see. So these are the connections for one can. These are another. This is another. This is the this is this one down here. And this guy connections are here. So this looks like the power transformer right off the bat to me at a glance. The tricky thing here is, let's see, the power comes in up here. The power's part of it sent over to this multi-part plug, goes over to the receiver. Receiver has the on-off switch. Power comes back somehow in one of these terminals. From there, yeah, I can't figure it out just looking at it. So that didn't get us too far. Now, how can I know these are capacitors here? Oh, it's one can with two sections underneath. See, these are all labeled here. We'll see that when I get the close-up camera going. So another thing that's got to be leaping out at you is this big blue resistor here, coming from one end up to the other. This looks like a little bit of asbestos here. Maybe the same thing at this end? No, I don't see it. It looks like asbestos right there. A couple other things that stand out. Obviously, these two capacitors are leaping out at me. They've got friction tape on them. Why? This one is taped onto this cable to give it some support. These could be in replacement of this or in augmentation of this. You see a floating connection here? In fact, I could looks like if these weren't taped, looks like I could pull them right out. Wire lead here. See, there's a lead disconnected here. There's no lead on this. One of the leads going to this huge thing is disconnected. Now, this is electrolytic. This is not. Okay, well, we'll take a closer look at that. There's a couple of wire wound resistors or rheostats up here. One is marked tone, this one's marked tone, and this one's marked hum. So this would be a hum balancing control on maybe one of the heaters or something like that. Okay, so these are the two 45s here. These are the two amplifier tubes. This guy is the preamp and this guy is the rectifier. Okay, so we look at the rectifier. Now the wires just disappear into a bundle and they reappear down here where this has to be the transformer. I don't think there's any doubt of that. I see three resistors here. There's a capacitor right there. And these two things are the plugs, the in and the out plugs at the top. Is there anything hidden away there? I don't think so. Okay, let's take a close look at this now. We've got kind of an overview of it. Let's see what we can see in a close-up camera. That's not very close, is it? So maybe it's on autofocus. Let's see what happens. Yeah, so I'm going to change the focus off of autofocus here because autofocus will give us headaches. I'm going to fix the focus up a little closer than that. How about like that? Okay, so we'll go in the top right hand corner and we'll just start looking. Just adjust the light here. Well, the first thing we're looking at are the connections to the big terminal. And what I'm looking for is just anything unusual. Oh, look, that solder, that bottom right one. It looks like the solder didn't flow onto the connector. It looks like it's sitting on the connector. Don't think it matters now after all these years. Now, all these wires are bound to be really stiff, I would imagine. This one is as stiff as can be. This one's stiff, but it's rotating on its yeah, these are all as stiff as can be. Bend any of these wires and the rubber insulation inside will crack, that's for sure. Okay, we'll go across the top. So this is the back of the power in plug. Nothing of interest there. Here's the rheostats. Let's take a look up at them. So I'm looking here to make sure the windings are all equally spaced. There aren't any that have been pushed together. That would indicate, as I found in another radio, that too much current had flowed through this at one point. The wires had expanded and come loose and then been knocked asunder. Not this one. This one looks good. Okay, we'll go on to the next one. See a little more variation. Oh, look how varied it is. Let's take a look this way. So wires do not seem to be consistently spaced here, but it looks like it's on purpose. The windings are close at the ends, but spread out in the middle. It sure looks like it's on purpose, though. I don't think that's any kind of breakdown happening. Okay, now we're in the top right corner, top left corner rather. Here's one of the resistors. These resistors I found to be quite reliable, oddly enough, even though, what are they? A bar of carbon with wires kind of wrapped and glued to it on the ends. But or are they soldered? I don't know how they make these lead wires attached to the carbon. Could just be just fortuitous contact, frozen up with some glue or something. So there's no sign that these are in trouble in any way. There's one. Let's look at the last one. They look perfectly fine. So everything looks original in here. Okay, we'll just keep going down the side here. It's just a big cable. Yeah. And we're down into the power transformer here. So I'm trying to see if these are original. Oops. There's the numbering. Well, there's no reason for me to think this isn't just the original. Lots of wires. Okay, now what's this? What's going on here with this black gook? What is that? So this, you can see it here. So this is how the big can up above here is held in. These heavy metal bent tabs. For some reason, the tabs on this side are full of compound. You can see compound leak all through here too. So this might be evidence of an overload at some point, or they just operate the radio for a long time. It gets warm and the compounds they put in here get soft and maybe they float. Don't know if that's really indicating a problem or not. But it certainly is different than the other side. That's one side. Let's get a look at it here. Where'd it go? There it is. That's one side all gooped up and the other side clean as a whistle. So there's quite a difference there. Okay, not sure it really indicates anything though. Now we're looking at the, we've come across to basically the bottom right hand corner, and we're looking at the big resistor. Now let's take a look at it. So is that asbestos? Oh, I think so. So let's get a really close look at it. So the trick in identifying asbestos is the crystals, as I was saying in an earlier video, the crystals, which look like fibers, are pieces of rock. So maybe they're, I can't be sure. It certainly has a look of asbestos at a glance. We have to get the microscope on here. Well, we'll do that when we're done. We'll bring back the microscope and we'll look at this stuff more closely. See if we can determine what's up. Now, how come this thing is white? Speckled with white. What is that? Blemish there on it. There's another blemish. So it looks like OLK2673. That must be the part number, and then it says 4,325 ohms. What, entirely? So I guess the whole thing, from end to end, is 4,325 ohms, not 26. Well, they ended in 5, so it means it's between 20 and 30. That's pretty precise stuff. So it looks to me when they made the resistor and they coated it, and they didn't succeed in coating the back end part of this terminal here. You can see where it's kind of gapped out. Likewise here. It's just a bad job. What is this coating for anyway? Possibly because what's underneath the coating is electrically energized and conductive. Solder job's not the greatest one there either. But back in the day, what were they using to solder? The guy probably had a coal fire beside his bench with a big iron sitting in the coal fire. Bring it out red hot, solder stuff. So nothing looks particularly wrong with this. The radio did work, so don't think these are burn throughs or overheating marks or anything like that. Just curiosity about the asbestos. I'm not really concerned about it. Okay, well, we just swing to the right here a little bit. We're at the back apron. Is that the back? I guess that's the back. So here's one of the two replaced capacitors here. You're not going to see much, other than this is just a regular capacitor. This guy is electrolytic. A little curious about that. My past experience is some of these old radios have very large capacitors in them that today would be electrolytic, but back then they made them non-electrolytically. Can I even say that? So an example of that is this one. I kind of skipped over this one in the middle here. So this metal can is a capacitor. There's the two attaching leads, and this is probably a fair size capacitor in here, probably a 0.1 microfarad or something like that, or maybe even bigger. And chances are this capacitor is perfectly fine. Again, with the radio operating, you can't be too suspicious that there's a lot of bad parts in here. Okay, well, that's a journey through. Oh, we're going to get the microscope out and take a look at this. Okay, let me get that fixed up here. So this is a look at the blue material. Just above it there at the top of the shot you can look at is just where the asbestos is. So I'm just going to move the camera in a moment, but look at the funny look of this material. It's not very nice looking, is it? It's really kind of icky. Okay, let's go up, which is actually down. There's the maybe asbestos material. The most likely asbestos material. See if I can focus this now. There's some great fibers there we can look at. Right there. Okay. See if I can get those in a little better focus. Now you gotta ask yourself, you know, what kind of material would they ever use in here? Now we can look more closely at the fibers. So what I'm seeing are bundles of fibers, and wow, it really has the asbestos look to it. Now this part, not quite so much. There's a lot of very straight fibers in there. I don't know what to say. I see lots of curved fibers in there too. You know, what material would they ever put in there other than asbestos? But it's just well, can't be sure. That's kind of the bottom line there. Cannot be sure. Okay, great. That's my microscope there. Okay, what have we found out about this amplifier by looking at it very closely? Not a lot more than was obvious at a distant look, really. Wasn't anything too revealing. These guys got to go. This guy needs to be tested. This guy needs to be tested, but he probably won't go. The shocking thing is, as far as capacitors go, that's it. A couple here, and I suppose these guys are capacitors. Yikes. But again, look, they're in a metal can. They're probably just fine. Or fine enough. Fine enough. We don't have to fool around with them or anything. If the unit wasn't working, or was working very, very poorly, I would be a lot more intent on investigating these things. But with the radio working quite well, we need to find out if you can do this. Can you put a electrolytic capacitor here? And really, what has he done here? There still are 4 leads connected. So the one in the middle here has a big red dot beside it. So we'll have to investigate how this is wired, what has been done here, and what we can do about it. Maybe we can continue with that on this video. Yeah, why don't we do that? We'll try to figure out what is this exactly, because it's not labeled in any way. It has the his master's voice. The dog listening to the dog listening picture. Okay, I'm going to try to figure out what this is exactly by looking in the manual for a bit. Okay, that little investigation was a little bit surprising. Let's take a look here. These are all transformers, every one of them. There's no capacitors in these cans. So this one is a big choke coil in the filter. This is a smaller choke coil. So this is the power supply filter. Here's the big power supply transformer that the power is hooked up to coming into the radio. These are transformers that are between, it says interstage and output transformers. So interstage must be between this tube and these two. This is the push-pull output tubes. And then the output transformer is between these and the speaker. And then here's an input transformer. So that's why this thing weighs so much. It's big boxes of copper here and no capacitors. So the filter capacitor situation. Let's look under here again. I got these two guys sitting here, but you know, those are replacements. I'm sure they must be. So what was originally here? What was in here to filter the to filter the power supply? Oh, let's take a look at the schematic here, I think. Okay, so I think I'm going to look on the schematic and try to find where these two capacitors are. That won't be hard. Where this gigantic resistor is on the schematic. I think that's going to be tricky. And then there's these three, you know what, they're not similar. I was going to say three similar resistors, but in fact, this one's a little skinnier than these two. Let's see if we can find what these are. So these are the heaters on this side here, and this is the grid plate terminals there. So it looks like this is connected to, it would look like it's connected to plate or grid to ground. That's what it looks like. Okay, let's take a look on this schematic now and see if we can figure something out here. Okay, let's start with the big resistor. So on this diagram, here is a big resistor with taps on it. But you know, the resistor in the radio, I'm looking at it right now, 1, 2, 3, 4, 5 taps, 2 at the ends and 3 inside. So how does that work on here? Maybe this R11 is really part of R6. So they're not showing it on the schematic the way it is in the radio. They're not showing one long resistor. So that's my guess. Now would that be enough? We'd have terminals on the end. And 1, 2, 3 terminals inside. Yeah, that's enough. So this R11 must be on the end, must be part of this big long resistor. That's what I think is going on there. Number 2, what about those capacitors? So there's 2 capacitors right here in the filter system. And there's another one there, C11. That's probably a small one. C11 across the this must be, I guess they don't use the field coil as part of the filtering system in this radio. They haven't figured that out yet. So I have a separate coil here. So what are these? C9, C10, C11. So over here are the parts list, quite handy. C9 2.5, C10 3. Now I can easily do these with electrolytic capacitors. It is a power supply. Well, there's another one, C5. I missed that one. So 9 and 10, I can only do them by electrolytic. I don't have non-electrolytic that are that large, and one of these already is an electrolytic one. So what about the C5 here, 0.001? That's no problem to change if I can spot it. And C11, 0.125 across this coil. You know, I'm starting to wonder if in fact these capacitors are all hidden inside that metal box with this coil, because it just doesn't appear that there were ever capacitors. these ones were ever visible, removed, and then these other ones installed. It just doesn't look that way to me. Maybe this is also, because I'm not finding these capacitors. Okay. Yeah, you know what? I think they're buried in the box. Now, let's see if we can find a diagram that'll show us the terminal connections on the filter choke. The filter choke. Let's look and see. Oh, this is, there we are. Perfect. So here's the filter block condenser. Filter block. Condenser. They're calling it a condenser here. Here's that big resistor. This is a very helpful diagram, this one, for sure. Bypass condenser. Wait a minute. Where is this? This does not appear to be in the radio. So there's a part showing right here. This condenser is showing. This is which one's this? Let's see. This is a bypass capacity 0.002. That's a very small capacitor. And this one, where's the arrow pointing to it? Oh, it says right on it, bypass condenser. But they don't put a value there. This doesn't exist in the radio. Is there something else? Anything else different? I'm just looking very quickly now at the different componentry. Terminals. Filter choke. Yeah, it looks exactly like that. What about this? There's its connection right there. I don't know what to think of that. There should be rivet holes or something if it's been removed. It should be easy to see that it's removed. Or is it up on top? Usually if it's on the other side of a panel or it's hidden, you know, they do it in dotted lines like that. They use dotted lines to show what you can't see directly. I don't know. These resistors, here they are. So, this is a great diagram here. 0.5 meg grid leak. Oh my gosh, I had no idea that's what about this one? Oh, this has got the same, look at that. 0.5 meg grid leak, excuse me. 3 resistors here should be the same value. 2 amp fuse. What? I don't remember seeing a fuse in there. There's no fuse in this radio. There's some variations here. You could see a fuse being added in later, especially when you see how they've drawn it here and they got all the wires all, they just sort of drew it right in, kapowie. So I think this came later. But this guy, did he come later? I don't know. You know what? There's no fittings for this capacitor. Does it have a number? Is there a part number? You know, there's nothing pointing at this. Actually, there's no part numbers on here at all, is there? On this diagram. It's typically the case that these diagrams, you have a number of different diagrams, but you can't relate them because they lack common information at times, common identifiers or stuff like that. Well, what to do about these resistors? Why? So 0.5 meg. Let's look on the schematic and see if we can find them on the schematic. Be on the grid. So you expect to find 0.5 meg on the grid. There's nothing here. What's going on? When I say there's nothing here, there's this R5. So R5, I already looked at this, is 800 ohms. Okay, so where's the 0.5 meg ohm here? Here we are, R9, 0.5 meg. Where does it say R9? R8, R1, 5, R9. Okay, so R9 is on the grid circuit of the 227 detector tube. So this is a grid bias technique being used here. So the grid will self-bias. R9's got nothing to do with the 3. R5, 800 ohms. I don't think I can find an 800 ohm resistor in here. You know what? This diagram is really not matching the radio. Let's just look at the other ones here. R1, R3, R120, R3, 400. Yeah, see, that's tied to the heater line here. That's a way to apply a chassis ground in a balanced manner, if I could use that word, balanced manner. This little deal here is part of all the heater circuits. And look, here's another one down here. It's a filter technique. Again, they're doing it off of each heater leg, 2 capacitors, and then a ground. That's to balance everything. I guess that's the best word I can use for it. What other tricky things are going on in here that I got to become aware of? So what are those 3 resistors that are standing out here on the radio? Let's go back and look at the radio a little more. So yeah, any parts up above? No, there's nothing up above. How could there be anything up above? There is nothing up above. It's all under here. So there's a capacitor that appeared on that diagram. This is where there should be a capacitor, or at least on the diagram there is, but there's nothing here. There never was. There's no holes. There's nothing. So that part was never installed on this radio. I gotta be just a little more certain about what these resistors are here. So why don't we? You know what? You know what I'm thinking? I'm looking at the radio, and there's a series of 26 tubes. So you see the same. So here, if that were the case, you'd see same. So same. No, that's not what's happening here. There's 2 output tubes, a preamp tube, and a rectifier tube. Nothing, not really part of this grouping here. So that's the rectifier tube, no resistor. It's doing something completely different from these guys. These guys all being amplifiers. So the signal starts here, gets boosted, and then it's fed into these 2 in push-pull. So these resistors are on the output. Oh, that's what it is. I'm busily looking at the wrong part of the schematic. I am really. Okay, let's look at the schematic again. You know, it's all part of learning when you do this stuff. You're just bound to make all kinds of initial mistakes. Okay, so where do we find, so here's R9, here's an R9. That's interesting, eh? So anywhere the same value of resistor shows up, they use the same number, R9. Here they are, there's the third one, R9. So this would be from the grid of this amplifier to the chassis. We should find R9. This one's a little tougher to read because it's across this winding here. Yeah, this one's tough too because it's across that winding. Yeah, where's the... Oh yeah, I'm remembering back to here. Don't remember back to there. My experience with these kind of resistors has been good. They're generally probably the same value they were when they were made. That's been my experience with these ones, this particular type. So maybe the way to approach this is not to try to measure the resistance, but to measure the circuit when it's operating. For instance, on that 226 tube, this one here, you could try to measure the grid potential. I I know this. I can change these two capacitors and not sweat too much. The rest of this... Oh yeah, we had to figure out the capacitor wiring. That's why... Okay, back to where we were. Back to where we were. Back to the future. So this shows 1, 2, 3, 4, and when I look on the radio, I see, yeah, right, 1, 2, 3, 4, with an additional fifth one sitting right here. Thank you. Thank you very much. How am I going to sort this out? This doesn't match. I'm frozen solid here. Let's take another look at the radio and just look right at this terminal and try to sort out what is going on here. Yeah, let's do that. So we're looking at these connections here. Schematic shows 1, 2, 3, 4. But on the radio, there's number 5 right here. Number 5 has had things soldered to it. They've been removed. You know what? This doesn't look like metal here. This looks like paper. This could be a connection to the... Wow, yeah, right. To whatever's inside this big mysterious box. The radio works with this connection gone. It looks like this connection is here now. What is this? What is going on here? So this capacitor, one lead there. This capacitor also has one lead here. The other side, what have they done here? What have you done? So there's a wire coming from here, and there's another wire, you know, it's got to be going to the bottom of this capacitor here, for sure. And the top wire is coming to here too, along with the wire from here. You can see the word positive written right there. This is supposedly the positive lead. That means this is the negative terminal. Negative of what? It's got two other chunky wires going into this cable, and good luck to us to find out by looking at the radio where they go. We won't. Well, in the picture, this terminal will be what it is in the picture. You know, pictorially, it's correct. So maybe we can identify what each of these terminals is doing. This one, that one. Yeah, what about that one? Good, nice ground point. Here's one. So my question is, so that reads 0. It's upside down, eh? That reads 0. So I think this connection point, the one I'm pointing to with my finger up here, the one that's clipped on here, this one. That's making it back to ground. Let's just try another one, see if I get the same result. Just in case I do. So that's 1.5K ohms. 3.4. More than 20. This is open. Not interesting. Open. Oh, it's not open now. Capacitor working away there. Short. Okay, so this busy terminal at the bottom. Sorry, you couldn't see what terminal I was testing there, but I will tell you. So the last terminal I tested with this one shows basically a connection to the chassis. Negative side of the capacitor, don't think this one's electrolytic. These two really do appear to be just in parallel. You just parallel two of them, but that only gives them one. Where's the other? So conceivably what's happened here is there's two inside. Somebody concluded one of them is bad, somehow recombobulated things. They needed to use two capacitors in parallel, installed them so they look like they're in series or doing something independent of each other in order to get the appropriate capacitance. I don't know. I mean, the story holds up, but is it true? Could be some more truth to be found here. So these guys are definitely leaving. So we will start the exodus here. Get a chance to look at them a little closer. Friction tape gives you a bit of a date when this was done. This would have been done in the maybe the latest that would have been done would have been 65, I think, somewhere around there. I think I'd be surprised. Well, I don't know. You know, you can still buy hockey tape. You could still use it in a radio. Hey, don't come off like this. There goes the info. So it's a little wax here, so it's peeling away easy. Get this right out of here. There. Electrolytic capacitor. I'll take back what I said about it. Oh, there's the negative sign there. So I think he's definitely paralleled these. Yeah, the value I think is written right here. Oh no, that's it there. Microfarads, 20 maximum. This is maximum 20 volts. That's bad, I would think, if that's what that says. But it's got MFD there. And this guy's size. I can nip them right out of there, can't I? What could go wrong at this point? Nip them out. They're definitely in parallel. That's all this is. Two guys in parallel. I'm going to nip that right there. High farad dry electrolytic condenser type PRS DC working volts. Yeah, so they would have written the voltage down here and another down here, and so this is, it's a 20 microfarad capacitor. This guy, what's that? Somebody's written on it. Looks like 450. DC peak voltage, handwritten 450. Under US patent. Where's the value here? MFD, and there's the value right there. Really? Wow, it's not helping. What are the chances? This is for the other guy. Looks like 350 voltage. Oh. Yeah. I think we're going to get this off. Read the back of that piece of paper there. I mean, ultimately, it may not really matter what was in here. It's what I want to put in. I have the schematic. This is just going to... This is not going to come off. X-ray? No. Ah. It's gone. Okay. Well, we'll never know for sure what somebody was up to. Paralleling a 20 and something. So that would be a 20 and something. Let's go back and look on the schematic. Is there an explanation for what he was doing there? So the filter, oh, that'll be on the schematic. The filter capacitors C9 and C10. That's got to be what he's fooling with. C9 and C10 have a connection made together that goes to ground. Okay, so that would be correct. The negative side of those two capacitors was connected and looked like connected to a terminal that went to the chassis. The two positive sides are connected together also. So it's either that combo is replacing this guy or replacing this guy, and the other original one is still in there doing its job. And somehow disconnecting that lead, which isn't shown on the diagram here, disconnecting this lead somehow was a beneficial move. Now, this could just be nothing more than a ground point. And it could be that, you see, maybe it was an unused terminal and they don't even show it on the diagram. Like, look over here. There's terminal 11. Here's terminal 13. Where's terminal 12? Where's terminal 13 down here? There's no wires connected to it, so they didn't bother showing it. Or is it missing? You know, I think it's missing. And I don't think there are. Let me look and see. Yeah, it's missing. So okay, that theory sounded great, but not true. Can we find any open terminals? Okay, well, we're not going to figure this out. I don't think what's going on here. We'll assume this is nothing more than another negative terminal point, and in that case, that case doesn't make sense at all. It doesn't make sense at all because this point is being used. Hey, let's trace some wires off of this. If we follow this one. It comes over here, one of the taps on the big resistor. Okay, well, you wouldn't expect this to be a ground point right in the middle here. Maybe this end, maybe that end, but right in the middle. What's going on? Okay, follow this one. Down to the transformer. No, wait a minute. How can this be a ground point if it's hooked up? Well, maybe that's the ground point on the transformer. I don't know. None of this is adding up right. Let's go here. This way. Ooh, I think this is it here. connecting to terminal 9 on the big port plug. Nothing's coming clear. Nothing is coming clear. C9 and C10, and C9 2.5 and C10 3. None of these are 20. None of these are close to 20. And these two are, you know, they're not in parallel. They're installed separately. Wow. Okay. Before I change those two capacitors out, I'd like to understand better what somebody was trying to do here. It looks like they took the time to parallel two capacitors together when one of them was already 10 times the size of what was needed. So why would somebody having a capacitor 10 times the size that they need want to add more to it? Unless, you know, this is one of these tricks where when this radio comes in for service, it commonly has a failure down in here, and the way around the fail, and this is inside the big tar-filled metal can. How are you going to deal with that? And the way you deal with it is you do what this guy did. Now, this terminal number 4 could be the missing terminal in the diagram, the chassis diagram. That would kind of make sense. Well, I'm really stuck here at this point. I got to go away and ponder what to do here. Could just go ahead and, well, you see, I can't even replace these two the way they are in the schematic. Look at this now. There's terminal numbers here. 1, 2, 3, 4, 2 again. Are these numbered in the radio? They are. They are numbered in the radio. Okay. We've gotten somewhere here. Look at this. This has 1. This has 1. They can't be the same one, can they? No. Okay, so I'm not sure what that number 1 is there. So between 1 and 2 is this. Between 1, so I can test this guy out. Between 1 and 2 is also these two capacitors. Internally, these two capacitors are grounded on one end. So if I try to read between 1 and the chassis, or between 2 and the chassis, the only way to get to the chassis is through a capacitor. Is that really true? Looks like it. What about this way? Head down this way. Yikes. That's going through the field coil here. So it looks like the field coil is used as a filter right in the output area of the radio, filtering the B+ that's heading to the plates of the two output tubes here. That's what it looks like. So the B+ here is fed. Oh, never mind. That was completely. What are they doing? So I guess they're just energizing the speaker. Again, they're not using it as a filter, I guess. Well, I can do some tests here. Pin, let's get this straight. Okay, so
to ground from pin 1 and pin 2. Let's go see what we get. I think we should get open circuit. Pin 1, pin 2 to ground.
Pin 1. Pin 1 and pin 2 to ground. Pin 1, ground being the chassis. We get it at 2,000 ohms. $4,000 ohms. Let's keep going just for fun. That's the one I think is just a ground connection. They have a red painted dot there. That's an interesting question. Why would they take time to dab some red paint there? This is showing open. Oh, no it's not. Charging up some capacitor somewhere. And that's showing a ground. Terminal number 4 appears to be grounded. Terminal number 4, grounded. Terminal number 4. So this is not, I was quite mistaken about this being the mysterious pop-up terminal. So what would the pop-up terminal be used for if number 4 is grounded? So I know 4 is grounded, so we can read from 1 to 4 and from 2 to 4. In either case, the only way, hey look at that, the only way to get a resistance reading between 1 and 4 is to sneak through this capacitor, or even this one back in from wherever. There's capacitors all around. So I should be able to read open circuit between 1 and 4 and between 2 and 4. It should be open. Wide open. Okay, let's go check that because I don't think it is. One and 4. The same as clipping onto the chassis like I did before. 1 and 4. Oop. 1400. 1400 ohms and 2 and 4. What do you think we're reading there? The leaky capacitors? These are all still connected into the radio. The only part that's been disconnected, so to speak, is this mystery terminal. There's some words written right in here. It's probably the manufacturer's name or something. Let's see if we can get a look at that. Hey, what happened to my focus? My focus is, oh, that's funny, my focus box is missing. I wonder what happened there. Must have been some flying mouse thing I did. Take it off auto. Okay. What does that say? Right in the red paint. Right in the red paint. Let's put a little special light to it here.
Just a number, like 8123, like a part number or something like that. That's all that is. Look at that. That's quite the mess there, eh? So who knows what wires have been moved around. Some of those, the snaky shape of the wires, the bending of them, looks like they've been forced there. Now probably the pin... Hey, wait a second. 1, 2, 4. This is 3. Hold on here. They've gone and fooled me some way. You see the number 3? Oh no. Oh, look at that. So on this radio, the mystery pin is number 3. Oh, and that's why this one becomes 4, and the pin I thought was 4 is 5, but it's the same as 4 without the 3. Everybody get that? Okay. Okay, so I get back to what am I going to do here? I don't know. The easiest thing to do is just duplicate exactly what was there. Throw in a gigantic capacitor and walk away. One capacitor and walk away. Or did I read the value on this capacitor wrong? I think that's 2.0. This is a big thing. Big thing. How can it not be 20? Hey, now look at this. This is kind of interesting. So it says, you know, DC peak voltage, and then it's handwritten 450. And then right above it says MFD, and it's actually, you would expect it to be out, you know, written out here somewhere. Well, the guy's putting in capacitors, he doesn't even know what size they are. Let's try and find out. Let's check the condition of these two capacitors. Let's do that. We can do that. I can do that. Let's do that. Let us do that. Oh, okay. Yeah, here. Okay. I'm reacting to something that doesn't need any reaction. Over we go. This will be the end of the video for today. Let's do these because I really should think a little about this before I jump in and end up making some kind of mistake. Positive. Wait a minute. Didn't I think this was the negative because I saw that line? It looked like a little dash. I saw that. And this is the positive end. Oh my gosh, what was he doing here? Like this. So it's positive to positive. Yeah, okay, I don't know. Maybe I just unnerved myself there unnecessarily. Okie doke. Okay, put your wagers down. How many want to bet this is a badly leaking capacitor? Now it's electrolytic, so they're all leaky. So I flipped this switch. Oh my god, it was already on electrolytic. It's the most problematic switch on this instrument is remembering this switch setting. So we're on electrolytic. I'm going to check with 50 volts across it and watch what the eye does. It just popped open as if there's no capacitor here. Just disconnect it. This capacitor appears to be completely, and we didn't make a connection. This capacitor is open circuit, I think. This guy will tell us. Let's say no or defective part or something like that. Let's see. So it says it's a capacitor. It's 4,000 picofarads. So that's 4,000 picofarads is 4 nanofarads, a 0.004. You think electrolytic capacitor is a 0.004? I think that's the capacitance of what's left of this capacitor inside. So I really think this is really a sick puppy. That's my determination there. Positive. Back down to 50. Just in case you can see the number on my machine, it says 25. It's actually 50 volts on these machines. Okay, we're ready to go. Here we go. Now that's more what you expect to see. That's showing up good. What's the rating on this guy? We don't know the rating. 150 anyway. Here we go. Takes longer to open because it's driving more charge into the capacitor. This capacitor is testing good. What that other one was doing there, I don't know. If this guy, well, okay, if he's testing good, we can read the capacitance. Let's try it. So the capacitance is, we think it's somewhere between 0.1 and 50. Watch the eye to pop open. Oh, here it is there. Anywhere else? Nowhere else. It pops open quite clearly here. And what do we get? So we're on the 50. Supposed to be 10, 15. It's actually smack dab on 20. Wow. Take a wild guess. Somebody put this in and then it didn't help, so they put in another one on top of it, so to speak. I don't know. I don't know how to explain how this is the way it is. And 20 is just, you know, this can be explained by somebody only having a 20 in their shop. A repair guy only got a 20, so it's going in. It could even, without, you know, listen, they didn't have this kinds of instrumentation back then, back when this was done. There's a good chance he had nothing like this, certainly nothing like this. And don't think he had a keyboard sitting on his bench at the time either. Could be he thought, well, this is 20 when it's new, it's probably 10 now, we'll stick a 10 in, this will do the job. I don't know. The reason I try to figure these out is because maybe there's something there I gotta figure out, or I'm gonna end up making some kind of ugly mistake. So the mistake would be to stay in my shop longer, because I got a few more, like an hour or two before the rain falls, to go and do something outside. I think I'm going to do. So thanks a lot for watching. I think it's pretty clear what's coming here. Is I'm just going to install one capacitor here, similar to the way those two were installed.
of some value I'll have to come up with, and then we'll carry on. You still have these resistors to poke around, this guy to poke around, and this one here, just to try to get a feel as to whether anything else is really dead or gone or bad. Okay, thanks for watching. See you on the next video.